Hi, we will present our work, Exploring Chart Question Answering for Blind and Low Vision Users. Chart question answering systems can parse a data visualization and answer to questions that users formulate in natural language. Many different chart QA systems have been and are being developed. They have the advantage of being able to provide users information about the visualization on demand without requiring users to directly engage with the visualization.
One application of chart QA systems that is being constantly mentioned is making data visualizations accessible to blind and low vision users, or BLV users. They are promising in that users can learn about the visualization purely through natural language without having to rely on vision.
However, though many assume that blind and low vision users will greatly benefit from the technology, no study has been done into if and how BLV people interact with chart QA systems, and especially about what questions they ask to the system.
We aim to address this gap with 3 research questions. We want to understand the BLV users' motivations for using a chart QA system, and we want to understand what kinds of queries BLV users ask to such a system. Finally, we want to inform future design of accessible chart QA systems. To answer our research questions, we conducted an experiment with 24 BLV participants through Zoom.
We used the Wizard of Oz setup where participants thought they were interacting with a QA system, while a researcher manually provided answers to user queries. The users were encouraged to ask any kinds of queries to the system. The researcher answered the queries using a prepared answer sheet if possible, or consistently answered the system does not know the answer otherwise.
We prepared a stimuli pool of 4 different real-world data visualizations, each with a different chart type. For each stimulus, we provided an alternative text that satisfies established alt text authoring guidelines. We then optionally included a data table that users can navigate with screen readers to see if its presence affects user queries. We also took into account the participants' interest level and familiarity towards each topic by asking them to complete a survey. Each participant saw all 4 visualizations in the stimuli pool with randomized order and table conditioned.
After the experiment, participants were asked several questions so that we could learn about how they formulate questions, why they want to use the system, and other needs and preferences.
We analyzed the collected queries using several different classification schemes. First, we used prior work's analytic task taxonomy. There were also plenty of queries not related to the data, so we marked them separately. Next, we checked if a query was a visual query, meaning that it contained visual reference to the visualization. For example, what is the highest temperature is a non-visual query, whereas how long is the tallest bar is a visual query. Lastly, we checked if a query was a lookup query or a compositional query. Lookup queries are simple queries that retrieve a single value, while compositional queries require more complex data operations. We also went through a qualitative coding process to find interesting themes.
Through the experiment, we collected a total of 979 queries. We found that participants asked queries with a range of different analytic tasks. Finding extremum, retrieving value, and computing derived value and filtering were the most common tasks. Also, 27% of queries were non-data, meaning that they were related to the context of the visualizations, such as the topic, or they were about visual composition of the visualization.
We also compared our queries to those collected by prior work from sighted people. We found that BLV participants in our study asked twice as more compositional queries and as many visual queries as sighted people. Whether the data table was provided or not did not have a significant effect on the participants' querying behavior. Through interviews, we learned that participants found the system to be very helpful. Notably, they wanted to use the system as a browser extension through keyboard input. Now we will explain some of our observations and how they can guide future design of accessible chart QA systems. We organized the discussion into 3 sections, corresponding to different parts of the system: parsing visualizations, parsing queries, and providing answers. Participants reused phrases from the alt text and data table to frame their queries. Correspondingly, QA systems should be able to understand users' utterances that are directly borrowed from or refer to the alt text. Contextual queries were very common, taking up 22% of the total queries. Queries like "Why does the graph increase and decrease in a certain period?" require the system to be aware of the context to be answered properly. The system should be able to understand how the visualization is situated and use this information to help answer the contextual queries.
Participants frequently ask compositional queries. To this end, the system should be able to parse such a query and break it down into a series of executable primitive data operations.
For sighted people, what terminology to use in query is readily available visually from the title, labels, and legends. For BLV people, however, there is no reference to rely on when generating queries. Therefore, we suggest that the synonym dictionary for BLV people be larger than those for sighted people. In addition, the system can prepare to answer for different levels of aggregation. For instance, the system can have knowledge of the relationship between day, month, season, and year, and use this knowledge to parse user queries.
The system should support rephrased queries, which can be more prevalent among BLV people because they might utilize more diverse utterances than sighted people.
The system should also support follow-up queries to reduce the cognitive load of BLV users who need to rely on memory to keep track of their previous queries. A variety of query formats, including binary queries and commands, should be supported by the system. We observed that participants asked binary queries to construct a mental representation of visualizations, confirm the scope of the data, or clarify their understanding of data-related facts. We found that BLV people use visual references as much as sighted people do, so the system should be able to parse utterances using graphical elements of the visualization. Here, the query asks something about the red bar, which is interpreted by using the specification of the digital visualization. There is no way for BLV people to evaluate the accuracy of the system, and they are not able to adjust their misconception by visually inspecting the chart as evidenced by our findings. Therefore, the system should be able to identify and communicate whether the answer to a query is obtainable from the provided data or not. Another possible approach is to provide BLV users the information about the degree of uncertainty of the system's answers. The participants wanted to learn about the trend in more detail than what was answered by the system. The system should be equipped with expanded vocabulary to describe trends and patterns.
Finally, the system should support answering contextual queries that are out of the scope of the data, because for BLV people, each interaction to search for external information can cost more than for sighted people. Lastly, several participants shared that it would be useful to know example queries before using the system. This is important because it is harder for BLV people to figure out what task to perform because they cannot look at the visualization, which is typically designed to afford a specific type of data analysis. Thank you for listening.